Okay, well, thanks everyone for joining. This is going to be my presentation, my first one ever, so I'm pretty excited. I'll start with who am I? I work as a data analyst, whatever that means these days. Essentially just testing code and feeding through data at a Vancouver-based investment firm. So we're what we call a quantitative investing team. So we invest in stocks using algorithms, and I'm part of a team that does that. I have an undergrad in finance with some mixed in math and CS electives. So I've been, I guess, frequently doing some sort of data science. I don't know, the entire team that I'm working on is very focused on pattern recognition with data. So I guess that is classified as data science. I also love spending time outside, especially when it's sunny and not raining like today, and challenging myself to learn new things, which is a big part of why I'm doing this tonight. I also really hate presenting, so this is kind of like a challenge for me. And at the same time, I've gone to a few of these, and I always find them really informative, but at the same time, I feel like after having prepared for one of these presentations, this has definitely been the biggest learning experience versus just listening in on one of the presentations. So if anyone's on the fence about doing it, I highly recommend it. So there's my pitch for that. Okay, so I chose the Real or Not NLP with Disaster Tweets competition. It's one of the beginner prediction competitions, which means that it doesn't have a reward at the end of it. It just is an ongoing competition with a constantly revolving and refreshing leaderboard. So I think after 2 months or so, it completely refreshes and your leaderboard score is gone, which is good or bad, depending on how you're doing. The competition is about using NLP or natural language processing to predict which tweets from Twitter are about real disasters or emergencies that could be facilitated or helped by relief organizations or news agencies to help get the word out there. And so an example on the right is a big challenge because sometimes people use words that indicate a disaster but are not actually in reference to a disaster. And I actually found this exact tweet, and it doesn't seem like the person knows it's being used in the competition, which is kind of hilarious.
Oh, I think you, sorry to interrupt, but I think you, if your slides have moved on, they haven't for us. So you might have shared the wrong screen.
Oh, interesting. Okay.
Yeah, I think we're not seeing the screen that you're seeing. So we're seeing the slides not full screen and...
Let me try again.
Sure.
There. You see something now
that's better.
Different. Thanks.
Perfect. Thanks.
Okay, great. So this is the tweet I was talking about. So this was, like, I guess, the challenging component of this competition, which is that a blaze could be considered a positive thing or a negative thing, depending on the tweet. So let's see. Is it changing? For some reason, when I press this, it doesn't change. Okay. Yeah. Maybe I'll just use this. Has anyone ever experienced this where they can't change the actual screen?
Yeah, it's usually when you hit the share screen button and it asks you for all the different options.
Oh,
it's usually because you hit like the window instead of the screen itself.
Okay.
It just moved.
Okay, it might have just been my computer.
It's moving again.
Okay,
Are you in presentation mode in Google Slides here? Yeah, if you go to present, so let's see. So that looks good now.
Okay, now it's going.
Yeah, seems fine.
There. Okay. I think it was just my computer not being able to perform.
Could be.
In any case. So why was I interested in this presentation? Well, I'm in finance, and as you can imagine, the markets are very much driven by economic data and what people are reading about economic data, and what may or may not even be correct. I've always had this question in my mind, like how much of what is being reported is actually right, how much of it is a mistake, and how much of it is driving so much money across the entire world. And I've been thinking about this question a lot, and this tweet by Donald Trump kind of emphasizes this. This was a tweet that was grossly incorrect. The correct statement is in over 10 years, not 100 years. And the tweet still exists today, and you have to scroll down pretty far in the comments to find someone saying this is not right at all. So it's a lot of things like this that make me wonder if this is something that is a machine learning problem or it's a fake news in general issue, and whether or not this can be approached by being fixed by machine learning. I was going to ask Bruce if he can ask if this is a correct statement or not. If you can ask GPT-3 if this is the correct statement or not, maybe it can fix this problem.
That would be fun.
I did do some research into how far we've progressed in the whole fake news era, and it's quite a challenging problem because of what we were sort of talking about in the preamble, which is that there's so much out there that's satire and opinion-based that it's really hard to define what in fact is true. And actually producing correct training data for these models is probably the biggest problem that comes along with the whole fake news issue. So that's kind of why I chose this NLP Getting Started competition. More just this question was bothering me, and I felt like it'd be interesting to see what the world is like based on it. Okay, so the actual competition, this is what the data set looked like. Pretty basic in comparison to other ones I've seen. The main column to focus on is the text column, which is the actual tweet. The other two columns had some missing data, as you can see on the right-hand table. The keyword column, it's still pretty unclear to me what exactly it was trying to get at or how it was chosen, because there was no information in the data set or the data set source how it was chosen. So that was kind of, it didn't lead me to want to use it or pay attention to it in any way. And the location column is pretty self-explanatory. It's where the user was located. And as you can see, the keyword seems to be what exactly is the disaster related to, but I'm still not sure if it was handpicked or like random. It seems like it was handpicked, but I didn't choose to focus on it too much. And then the location is very much USA based, which makes me think that a lot of users are from the US, which makes sense because Twitter is a US company. So I felt like that wouldn't be very helpful in my adventure in this competition. Out of curiosity, in terms of what are the most popular words that came across both of the categories, it seemed like links to websites were very common in both. But for the most part, it's pretty clear what sort of word is in a disaster tweet and what sort of word is in a non-disaster tweet, at least in terms of the ones that are most popular. One thing I learned is the word bigram through this competition. Sounds a lot more complicated than it is. It's basically two words. A unigram is one word. And something that was pretty interesting to look at was to see which are the most common two-word combinations across the training data set. And as you can see, HTTP and HTTPS were very popular. And this sort of analysis was done right after I cleaned the data set of any punctuation, but I'll get into that a little bit later. So in terms of the distribution, I wanted to take a look at how many examples were of not real tweets and of real tweets. And it looked
Can I ask
pretty.
a question?
Oh yeah, absolutely.
Was this entire data set only in English?
It was only in English, yeah.
Okay. Thanks.
So yeah, as I was saying, the distribution between classes was pretty even. And I was also curious to see how many words were in a real disaster tweet or a not disaster tweet. I had the assumption, or I guess the hypothesis that a real disaster would have less words because people would maybe have like less time to really focus on the details and just get the word out there. But it seemed to be pretty even in that both non-disaster and disaster-related tweets had the same amount of words in them for the most part, which was pretty surprising to me, but interesting nonetheless. Okay, so how was this competition scored? It was based on something called the F1 score. If you haven't heard about this before, it's just trying to look at a balanced representation of two concepts called precision and recall. So precision tries to look at, out of all of the things that you predicted to be true, how many of them were actually true. And it tries to balance that out with something called recall, which is out of all of the true values, how many of them did you actually select? And both of these come with trade-offs, and the highest score would obtain an F1 score that was the highest, which was a combination of the two. The leaderboard for this one was interesting. I'm curious how it's going to change after GPT-3, but maybe a lot of them were using it already because there was a ton of 1.0 scores, which a lot of people said was because the data set is in fact public and people can look up the labels and then submit them, which I don't know why. It seems kind of pointless. But it's also pretty obvious that they're doing it because I'm pretty sure 400 people are not using GPT-3 yet. But the ending score I was able to get was 0.80, which is about 500 on the leaderboard at the moment. So I was happy with that for now. All right, so in terms of the data cleaning steps that I attempted, this is probably where I spent most of my time just because there's so much that you can do with text that I didn't realize. And I tried to use the matrix on the right to really guide myself in this process. So tweets, obviously very noisy. And I would say that this would be pretty sparse data. Like it wasn't a huge data set, like I think only 10,000 entries across the entire thing. So it would indicate some pretty heavy pre-processing, but I didn't actually use...
Minimization.
Pardon?
Oh, sorry.
Is that a question? No? Okay. So in terms of the data cleaning steps I attempted, the ones that I did most was to change everything to lowercase and to remove a lot of the punctuation. And then I played around with the last three steps, which are common in NLP problems. Something that people often do is remove stop words, which could be something like the or at or something else. Along with stemming, which is just changing things from plural to singular, and lemmatization, which tries to return the dictionary form of the word. So instead of running, you would get run. And it would be interesting that not all of these steps would improve my score. And it was also like a lingering question at the back of my mind, like if my training data set is so clean, but my data set that I'm trying to predict on is so messy, it was just, I didn't quite wrap my head around why cleaning my training data set would help that much. But
just a quick question.
Yeah.
I've noticed in the word cloud that you had non-value words like HTTP, HTTPS, words that don't tell us, I think, a lot of things about the fact. Have you tried to remove these words from the
yeah, in the end, I did end up removing those and a few others that were just very clearly not helpful and overpowering to the data set. But those two I did end up removing.
And why would you not apply the same cleaning steps to the test data?
Not the test data itself. I did apply to the test data as well, but more I was just curious in general, like when we're submitting my predictions, like if this model were to be used in the real world, I'm guessing you would also try and clean the data that you're trying to predict on, or maybe you wouldn't. I don't know. You would? Okay.
At least that's my understanding. As I said, I'm not someone who works with predictive models in her work, but so far from what my understanding is, that's what one would do.
Okay, perfect. Then that makes more sense to me.
Unless somebody else is like, hello, this is you experts who use this stuff in your work. Isn't that what one would do?
I'm a hobbyist, but I'm sure you would apply the same cleaning rules, for unknown data as well.
This is Alicia King. So a couple different groups that I've worked with, including a team for Washington and Oregon, we do a lot of analytics on real-time data because we're emergency managers. So our whole focus is disaster management. So we've actually done a lot of this work operationally in the field. And this is very similar to the process that we use, except I'm doing a lot of these functions manually. So we set up a lot of tripwires and identification of conversations that are being had. And we know based on experience, we kind of pre-season a spreadsheet of terms that we remove from searches. So if we're monitoring, for example, Air Force One, when President Obama was coming into SeaTac, we did a search for Obama minus Obamacare, or when we're monitoring for security purposes for protests, just to keep people safe, we may remove specific political references or references to advertisement because you get hashtag hijacking and there's other behaviors. Anyway, happy to chat more about that. I want to hear more of your presentation, but as somebody that's actually done this work for disaster management, I am delighted by what you've accomplished so far.
Thanks. That was really interesting. I didn't realize that, because a lot of what I did was actually using packages and libraries that were already automated. Like I didn't try and do any of this very manually, except for a couple words here and there. So that's pretty interesting to hear.
Sorry, my name is Nicole, and I have one quick question. Sorry about this. And my question is, did you ever have to deal with the missing data in your data set that you were cleaning and structuring? And if you had to deal with them, what was your approach?
Yeah, I didn't deal with missing data in this one because I didn't really use the keywords and location columns at all, which were primarily the ones that had missing data. All of the texts were there out of the ones that were in the data set. So I guess thankfully I didn't really have to deal with that in this presentation, but I know a lot of other competitions you do have to figure out a smart way to deal with that. Okay, so the whole process of turning words into vectors is something that we have to do with NLP. The very, very basic version of turning a word into something that our model can process is called bag of words. And this is a way to represent text as words within a document in matrix or vector form. The way that you can think about it is on the left-hand side, or the rows would be the tweets, and the columns would be a list of the sentences that were involved in each of the words that were involved in the tweet, and then a 1 or 0 whether or not the word existed in the tweet. And this is a pretty basic version of how you can represent words as vectors. There is another version, which is an improvement, and it's called TF-IDF. I don't know how people acronym NIMBUS, but it stands for Term Frequency Inverse Document Frequency. And while the name sounds very unintuitive, it's a pretty intuitive explanation for why. An example of, let's say you're trying to analyze tweets only relating to cats. Because cat probably appears so frequently in those tweets, it would be given less of a weight in comparison to a word like dog, which likely would not show up as much across all of the different tweets. So dog would have a higher weight, whereas cat would have a much lower weight. So it essentially just tries to downweight the frequency based on the frequency of a word showing up across all your examples, or in this case, tweets. And so I tried to use both of these different types of vectorizations to look at the data. And the way I did this was looking at what you can call embeddings or sentences, and trying to reduce the dimension of the data to see if there's any clear pattern between the two types of vectorizations. So I reduced it from like 20,000 dimensions to 2 dimensions so we can actually visualize it. And from what it looked like, Bag of Words did not really separate out the sentences or tweets into 2 clear groupings, whereas TF-IDF kind of did. It still wasn't great, but it still gave me more hope for using a model than Bag of Words did.
Can I ask a question?
Yeah, for sure.
I'm just curious, what kind of dimensionality reduction algorithm did you use?
Oh, I just used PCA.
Cool, thanks.
Principal component analysis. I have a bad habit of using acronyms from finance. So hopefully if I say something that doesn't make sense, please let me know. Okay, so the great thing about a getting started competition is that if you've never done one of these before, they literally give you a starter notebook with a solution that you can use to submit for a score. And it's a great way to sort of see how they go about approaching the problem as a whole. And the starter version that they gave you uses a model that is based on ridge regression, or it's called ridge regression. And it gets you to a score of 0.78. And the theory or intuition behind it is that the presence of a word is very linearly related to whether or not a tweet is a disaster or not. And thinking, I think, behind why they used ridge regression instead of its partner lasso regression is that they didn't want to completely remove some of the words. So if you would use lasso regression, you would push some coefficients to complete 0, whereas ridge regression would just make them very tiny instead. So this one wasn't really intuitive to me as to why they chose to use ridge regression. To me, it made more sense to use logistic regression. And so I attempted to use logistic regression on the Bag of Words vectorization first. And the interesting thing is that I got a better score when not scrubbing the data and performing all the steps that I mentioned versus when I did scrub the data and use this method. I don't have a good intuitive reason for why that is, but it's possible that the higher weighting on more important words actually made a huge difference for the, sorry, what I meant to say is that Bag of Words might have just more like random vectorization, and it helps to have a dirtier data set. I don't know, I'll stop talking. But it didn't really intuitively make sense to me. I'd be curious to see if someone has an idea of why that would be. And one good thing I thought, that looking at the confusion matrix, when we're looking at false negatives and false positives, was that false negatives were higher than the false positives. So intuitively, I would think that if you were to send out resources for a disaster that was not actually a disaster, that would be a bigger problem than if you were not to send out resources. for something that was a disaster, because that's kind of like the base case today. I think you still have to call 911 for resources to be sent out. So I thought that was a good thing for this model.
Can I ask you a question?
Yeah, for sure.
So relevant to the leaderboard score and the confusion matrix that you had on the last slide, it seems to me that there's, given a binary classifier, it must be possible to undergo a search for a threshold that yields a maximum F1 score, if you know what I mean. Did you like, and then, I mean, in this case, for example, like this confusion matrix, was this constructed with like a threshold of like 0.5? And
I don't actually know. I could say yes, but I would just be guessing.
Okay, so probably then, yeah.
Yeah.
So, because yeah, I mean, something you were getting at is, of course, an important and interesting topic, which is that, like, yeah, the costs of certain types of errors are like dramatically different, and so, like in practice, we might
weight them,
prefer a model that goes one way or the other, and then we also have this ability to, by changing our threshold for what constitutes a disaster or a non-disaster tweet, like by playing with that, we might play with those ratios, and we might actually be able to manipulate our F1 score just by changing that threshold.
Oh, that's interesting. Yeah, I didn't try that.
I have another question. Oh.
Sorry,
Lorenzo,
that's an interesting topic. If the disasters are equal balance with the non-disasters, the classes are balanced or not?
Oh, it's slightly not balanced. So there is slightly less disaster tweets than there are non-disaster.
Not so sure.
Yeah, sorry, just one question here. You did this in Python, right?
Yes.
So this is just like something that, like, I don't think a ton of people know, and it is worth pointing out. So in logistic regression, in the like the scikit-learn case, if you use scikit-learn, it actually is regression by default, and it's just like not pointed out very much. But this is like a very common thing. I just wanted to throw that out there.
Oh, good to know. I did not know that. Thanks. Awesome. So I took a look at what some of the coefficients were that were the highest using the previous approach, just to see if it made sense at all or not. And some of the words for the disaster category did seem like they were related to disasters, but some of them were, I think, pretty random. So I didn't have a ton of confidence in what was going on. So I kept trying. And also the leaderboard score wasn't that great as well. And so my next attempt was using logistic regression again with TF-IDF instead. And that's how I got the highest score that I was able to get on the leaderboard. And this score came after scrubbing the data. And again, I saw more false negatives than false positives. And when looking at the coefficients, the highest coefficients from this model, it seemed like it was much better at determining which words were related to a disaster, particularly in comparison to what I used before. So I was really happy.
This word, whoa, I mean, what is that? Is that even a word? Am I showing my age? Is that something kids are saying?
I've literally never heard that as well.
Yeah, okay.
Sorry, I have a question.
Yeah, sure.
Sorry. Actually, I have a question on the prediction accuracy, the method that you applied. I think you applied F1 score for the regression model that you use. I thought that F1 score is really hard to use with the like a ridge regression or lasso regression, for example. So I just wanted to ask, how did you actually, what was your approach using F1 score on those regression methods? I thought that usually we use a mean absolute error or mean square error or root mean square error to predict
Yeah, I don't know if I mentioned, but that was actually something that they chose. So like they give you the F1 or like they don't like give it to you, but that's what your results go through when you submit your predictions. So I didn't have to actually like deal with the F1 score itself, if I understood your question. I don't know if she's still there. Good? Okay. Okay. Um, so that was kind of how much progress I made in the 2 weeks that I kind of worked on this. I'm hoping to keep going on it and see if I can pursue these other strategies that seem to be helping the top leaderboards. So the first one that I'll just talk about a couple of them that I thought were interesting, not in any real technical detail, but just to give people sort of a heads up that they exist. And if you want to join me on this adventure, feel free to message me. But the first one that I'll talk about is called Glove, and it's based on a more basic version that you might have heard of called Word2Vec. And it's a word vector technique. It's very, Glove is based on this Word2Vec technique, and it tries to cluster together very similar words and repel words that are quite different. And it essentially just builds a huge document that is consisting of a bunch of tuples where one of the tuples contains a word and then a word in the context of that other word. And then it tries to use a neural network to predict the context of that word. And it only relies on local information, whereas where Glove is different is that it will try and capture both global and local statistics. And the key idea behind it, from what I was able to understand, is that you're able to derive relationships between words based on something called a co-occurrence matrix. And so that's going to be my next step in trying to get a higher score, and hopefully it helps. And then it seems like the top leaders are using something called BERT, which is decently new. I do remember hearing about it last year, but not knowing what it means. Now I kind of know what it means. It stands for bidirectional encoded representations from transformers. The intuition behind it is that a bidirectionally trained model has a deeper sense of context than something that's just single direction. And you often find bidirectionality in things like RNNs and LSTMs. So the idea behind it is not necessarily new, but the new component of BERT was that it had this transformer model, and the encoding of the words are dependent on the other words in the sentence. And that was the sort of novel technology that BERT brings to the table. But it's quite complex, and I really want to understand it before I use it. So that's kind of why I didn't yet. In any case, that was sort of my presentation. I noticed literally right before this presentation, Kaggle sent out an email about another Getting Started competition that's going to try and look at the differences of sentences and the entailment of sentences, whatever that means. And so I think BERT might be an interesting approach to that one as well. So just a heads up if anyone wants to try their hand at either of these competitions. They seem to be quite related.
Sorry, I asked a question earlier and then my internet got disconnected. So I couldn't finish. I don't think I was able to finish my question. So I'm sorry about this. Yeah, I want to ask my question again. Sorry.
Sure.
So my question was, I actually tried, I tried to apply the prediction accuracy method on the ridge regression before. And then when I did, actually, I used like a mean absolute error or root mean square error. But in your presentation, I saw that you were able to apply F1 score for performance evaluation matrix. So I just wanted to ask, what was your approach to be able to use that on the ridge regression?
Yeah, I don't know if I answered this properly, but from what I understand, you're just asking like, how was I able to use that score to evaluate myself? Is that true?
Actually, because I think F1 score works well with other type of model, but not the like regression such as ridge or lasso or like even multilinear regression. It wouldn't work with those kind of models. So I just wanted to, how did you?
Sorry, is it all right if I jump in?
Yes, please.
So there's kind of like two things going on here, right? So for ridge regression, you're trying to like iteratively solve something, right? You're optimizing towards like the best line that is going to predict whatever. Yeah. And that's where you would use like mean absolute error or mean squared error or any of those. F1 score is actually for like after you've done that optimization step and you're just like evaluating it. So you're not actually using that in the optimization step itself. Probably the closest thing that you would want to do is you can have like a balanced sort of mean squared error if you want to go that way. But yeah, you wouldn't use F1 directly on the thing that you're trying to optimize if it's ridge regression. Does that answer your question?
So technically, I won't be able to use F1 directly on those regression, right?
Right. Yeah, you won't be directly optimizing for it, but you'll probably have. There are metrics that you can optimize for that will get you roughly the same thing. What it tends to come down to is you want to balance like basically if you want your F1 score to be high, you want to punish very badly if the rare class is missed, right? So you just have to increase the weight on that. And I'll see if I can find like the scikit-learn instructions on how to actually do that, but it is possible to do.
Okay, I see. Thank you.
Hey, Matt, on that quickly. I thought you could, when you're doing like a grid like search CV, couldn't you set the scoring to like F1 or precision?
Yes, you could. I'm just talking about the direct like optimization step inside of ridge regression, which I just looked up. You can change that through class weight as a parameter in scikit-learn. I'm just going to post that in the chat if anyone is interested.
Yeah, thank you.
Perfect.
Jen, earlier you mentioned a specific case where you found you got better results without scrubbing your data.
Yes.
Maybe can I ask you to just refresh what it was that you did and did not do between the two cases?
Yeah, so one of them, when I didn't scrub the data, I used bag of words as the vector technique. Whereas when I did scrub the data, I used TF-IDF, and that got me a better score.
Right, but in this particular case, on this slide, you're saying that 79926 was better than what you got if you switched on the scrubbing.
Yeah, exactly.
And scrubbing, what did you mean? That was this like that things like stemming and
I only did the first three, yes. So removing like punctuation, then removing stop words, and then everything lowercase.
So when you don't clean up a tweet, for example, words that are all caps are considered different from words that are all lowercase?
No, that was just an example. Like if you wanted, you can do all text lower or all upper, but I just chose all text lower.
Okay, because I just think, I don't know. I was just like wanting to explore the issue a little because, for example, like I don't trust tweets that are all caps. You know what I mean?
Totally.
And so if you clean that up, you might be losing important signal.
Yeah, that's a good point. Yeah.
To what extent do you have confidence in the leaderboard scores? So, for example, if you did two different things and you made two different submissions to this competition and they had different scores, would you think that was a statistically significant empirical result that you could walk away and say that this is definitely better? Or do you think that the test set might be small or invalid or imbalanced?
Yeah, no, I think it was probably way too small for me to end up being actually happy with it. Just from what I saw on their website.
How big was the test? I think maybe we saw that the training data is like around 2,000 or something, judging by your
7,000.
confusion matrix. 7.
Ish.
That was training data was 7.
Yeah.
And then how big was the test set?
I actually don't quite remember off the top of my head. Oh, sorry, no. Training was 4. Yeah, I don't remember.
Yeah, I'm looking at the training set here. It was about 7,700, something like that.
Okay, good. Yeah.
Hi, Jen. This is Jude here. You said you didn't have confidence in one of the sets of data, and you had to.
Oh.
The other.
Not necessarily not confidence in. Do you mean the columns or?
No. When you showed the disaster versus non-disaster.
Oh, right. That was after using bag of words with logistic regression. The resulting coefficients in the disaster category, some were pretty not disaster related. Like, I don't know what X1392 is. Or Ryan's is.
Oh, I see. Okay. Yeah, that makes sense. Thank you.
Is this a case? I'm maybe asking people who might be more familiar with this particular model. Is this a case where we might consider some regularization? Do we think that these might be examples of overfit? Like only one tweet ever contained X1392 and it happened to be disaster, and therefore it overfit to a large coefficient.
Oh, interesting.
Which model did you end up using? Was it just bag of words, or was it the TIFD?
I ended up using this one, yeah.
Because that should balance out the weight of the coefficients for example, the next slide, sorry. That should balance out the. Actually, never mind.
It might make it worse, right? Yeah, because the one word that only ever appears once now is has a massive TF-IDF score.
But I thought that's what TDIF did. I thought it balances out to make sure that, for example, if it just shows up in one disaster case out of one disaster case, then it weights it so it doesn't have as much of a bearing on the overall model.
Oh, sorry, it's the opposite. So if there's only one showing up across all the tweets, then it will weight it higher. It just tries to get rid of very frequently used words that might not have a lot of context or significance.
Hey, Jen. Typically, I dropped this in the chat. Typically, when we're looking at assessing the likely validity of information online, we look for a couple of qualifiers. We start by filtering out calls for donations, hashtag hijacking, the thoughts and prayers kind of empathy expressions, which tend to be about 50% of communication in real world disasters. Oh, and then from there, we pull out some unlikely statistical outliers, or usually language outliers. It really does help to identify local colloquialisms. For example, issues that happen in Portland are usually tagged as PDX, which is the shorthand for their airport, but used colloquially by local people as shorthand for Portland. So for disasters, if you can pre-season search terms based on local language, idioms, etc., it has been helpful to us in filtering out some of the noise and assessing validity. But that's a volume issue because botnets and other things have gotten smarter, so they pick up on that language. Oh, wow. But that's operational practices that we're using right now.
That's really interesting. Yeah, I wish I didn't look at the original data set, but I wonder if they give cities, I think they do give cities as opposed to just countries, which would be helpful.
Wouldn't the presence of donation requests mean that this is a real disaster in this context, rather than something that does not relate? the sky's ablaze, look at the wonderful sunset, and there's no donation request. Like, that's not a disaster, it's just a pretty photo. Versus, that's the big one in YVR, donations for YVR victims. Like, sorry, guys.
No, you bring up a really good point. So you can use the collective body of language to assess the likely validity of a disaster. So that's determining whether or not the disaster is real.
Yeah.
The other thing that we're dealing with is malicious misinformation, which is also known as disinformation. It's a component of, honestly, asymmetrical psychological warfare. That's not an exaggeration. So when we're assessing whether or not the comment about the real disaster is real, for example, we had a train derailment in DuPont, Washington. Within an hour, I had conspiracy theories, QAnon style, that we were trying to dig through, figuring out if they were real. They did not meet up with NTSB, or National Transportation Safety Board, so first responders were not seeing these. So we started vetting against, we knew the disaster was real. We could confirm that pretty easily. The next step was to determine if the calls for assistance were real. And those are actually two kind of separate actions.
Right. Just like in COVID, we've seen people asking for donations and food and money and whatnot. And it's hard to figure out which of these calls are, like, what the need is behind those calls.
Absolutely. And a lot of there tends to be a lot of reverberation from official platforms. For example, people retweeting the Red Cross saying donate, text 555 to donate. Well, that's good, but it's not really relevant to disaster response operations. So if I can filter out all of those retweets and that reverb, I improve the signal to noise ratio, and I can dig through the remaining content a lot easier.
Because your quest is to find any new development in the disaster area in terms of, I don't know, now the train derailment, there's actually nauseous chemical leaking or something, right? Like, there's a new development that changes the extent of the disaster. Is that?
Yes. Often we're looking for complications or what we consider compounding or cascading impacts, but that's very accurate.
And in this Kaggle competition, it was the whole premise was this one tweet, does it relate to a real disaster, yes or no? Is that correct, Jen?
Yeah, exactly, yes.
So it's slightly different goals that go into how to treat the text and how to sift through stuff. I still wonder what whoa means.
Hey, Jen, thank you very much for that. That was great. So you've kind of shown the full spectrum in the classification realm, right? You've gone from bag of words into a logistic regression all the way through to bidirectional transformers with BERT.
Yes.
I wonder if you or anyone else is aware of more advanced techniques for actually cleaning the text, because if you give us a Wikipedia article, then a good stemmer and lematizer will do a great job, but tweets are troublesome.
Oh God, yeah. And I had to also figure out how to filter out emojis too, which was like a whole other thing. I don't have any good answer for you.
Thanks.
Wait.
Actually, we need embeddings for emojis, don't we?
Yeah. Why would you?
They already exist.
Out?
Do they? Okay, I did not know that.
Yeah, it's kind of neat because they use that also for like sentiment analysis and stuff like that.
Oh, interesting. Okay.
Like, we don't have a sarcasm detector, but some emojis do act as proxy sarcasm.
Oh, that's so funny. That's so true.
Markers.
That was actually an episode of South Park.
Oh, was it? A recent one?
Emojinomics.
Oh, man.
My favorite is when they use the location when people use the location on Twitter. and they did a sentiment analysis with the emojis, comparing people in the United States versus people in Canada, actually, and kind of how the sentiment is around the different types of tweets. And people in the States tend to use the skull emoji and the anger emoji quite often, with, kind of more anger sentiments. And then in Canada, a lot more smiley faces and just happiness. So I thought that was pretty interesting.
That is so interesting.
And unfortunately, there's no emoji for I'm sorry.
I was going to say that.
So I grew up in the U.S., moved to Canada 16 years ago, and something that I've found very interesting is that the number of violent metaphors that Americans use is much, much higher than in Canada. I had to change my own language to stop using violent metaphors.
Jen, thank you very much for the great presentation again. I have just one more quick question. I see that you walk us through which model that you have applied from linear regression or ridge, and then you end up using a logistic regression for this. But I just wanted to ask, did you get to use other type of classification models, like, for example, decision tree or random forest model? Did you ever
try those?
Try those, and then how that would work out in your data set?
No, it's a good idea though. I did want to. I was kind of trying to understand what I was using, and I only did this in 2 weeks. So, it's on my list of things to try. But I'm also learning about the models as I'm using them. So it's taking me a little longer than expected.
For people who are a high above in a leaderboard, do you happen to know what model they apply to get the best?
Yeah, sometimes they post their notebook, sometimes they don't. A lot of them that do post their notebook, it's Glove or BERT. That's the only two that I really see. So, yeah, that's why I mentioned them.
Okay, thank you.
How long have you been doing this computation?
I started 2 weeks ago.
Oh, it's only 2 weeks.
Yeah.
Amazing. So, I'm not aware of how this Kaggle computation works. So it doesn't matter how when you enter the computation.
So this one is a special one. Any of the getting started ones or the introductory ones that don't have a prize at the end of it, it doesn't matter when you start. The ones that do have a prize associated with them, it does matter that you start before the deadline. And they usually have deadlines of 4 to 6 months, depends, 3 months.
Oh.
It'll say the information though on the competition description though.
Okay, thank you.
Jen, this is Junior. I was curious to know, if you get stuck, is there any mentor help or?
It depends. I've tried to post questions on the discussion board, and sometimes they'll get answered, sometimes they won't. But a lot of the notebooks that people post are incredibly helpful. I think you get points if they are upvoted a lot, so there's an incentive there, I think, for people to post them. So in terms of resources, there's a lot out there, but in terms of one-to-one contact with people that know what they're doing, that one's a little bit more hit or miss.
Okay. Yeah, my purpose is just to learn, how to not to win the competition per se, but learn and put to the ringer, so to speak.
Yeah. No, there's a lot of really good getting started competitions with good beginner notebooks as well. So I highly recommend them.
All right. Thank you very much.
Yeah, and I can say just broadly, what you learn by jumping into a Kaggle competition with 2 feet and just trying and failing a lot and struggling a lot, but learning a lot as you go. And I think it's great. I think a great strategy is to pick up a starter. And so, yeah, and I guess in these competitions these days, there's like a starter notebook. In others where there maybe isn't, people publish such a thing. I think you don't learn a lot by copying and pasting someone's code, hitting the go button and walking away. But like, I think it's a great way to get you in at the, maybe not the deep end, but like halfway down the pool. And then you can start fiddling. And I think earlier during the introduction, somebody was saying how they were, looking for the courage to enter a Kaggle competition. I think a Kaggle competitor is essentially anonymous in an enormous crowd, and nothing is expected, and no failures are seen or judged. And so I think, especially as a beginner, thrashing around helplessly is an amazing way to learn how to swim.
Do expect to lose a lot of hours in the day, though.
Yeah, and if it turns out that data science is something you like and modeling is something you enjoy, then it's going to eat a lot of your time. Warning, but then you might have found a great career.
Right. Thank you very much.
I don't hear another question coming, so I'm going to put a soft punctuation here that you can clean out later
I was just gonna say.
when you're classifying phases of the presentation. And so I'm going to thank Jen for her presentation. I'm going to encourage everyone to give a round of applause. What we're going to do is we're going to allow people to unmute themselves when I count to 6. And then when I get to 6, we can give a round of applause. So I'll go on 6. 1, 2, 3, 4, 5, 6. Yay!
Yay! Well done.
Okay.
Thanks, guys. Great questions.